Hey, welcome back. This is an important day because today we're going to talk about decimals. And decimals turn out to be the key to really understanding the real numbers in all their glory. So let's get right to it. I know you've worked with decimals before, but I want to make sure that everyone's on the same page. So, like for example, knowing what decimals are. Well, it turns out that decimals are just simply fractions in the tens family. So fractions like tenths, hundredths, thousandths, etc. Now that's really good news because if decimals are really just simply fractions in the tens family, then we're going to be able to draw upon our, at this point, extensive knowledge of fractions to help understand decimals. I think we're going to be good to go. So the decimals really are just going to become this new writing system, a different way to write these numbers that we're already familiar with. So for example, if you've got some fractions like 7/10ths or 31/100ths or 549 thousandths, in this decimal system, we're going to write them as 0.7, 0.31, and 0.549. So what we're going to need to do now is we're going to need to make sure that we understand what's going on with each of those places. They must be meaningful. So let's do that. So like with the 7, the 7 is just to the right of that decimal point. What does that mean? Well, here's a decimal that'll help us explore that. So here's a long decimal. And we got our decimal point. And just so you know, to the left of that decimal point, those are the normal place values that you have known and worked with for years, like ones, tens, hundreds, thousands. Okay, now we're going the other way. We're going to go lower than 1. In that first decimal place to the right of the decimal point is tenths. The next place over to the right is hundredths. The next place, which is currently occupied by a 0, is the thousandths. 10 thousandths, 100 thousandths, millionths. Now, just want to point something out. Look at the green labeled ones. Thousandths, 10,000, 10 thousandths, 100 thousandths, and then millionths, this new name. Okay, that pattern's going to continue. Check this out. We've got millionths, then 10 millionths, 100 millionths, and now it's going to be a new thing. What do you think it's going to be? Nice. I knew you were going to get that. Billionths. Then 10 of them, 100 of them, new thing. Trillions. Wait, trillions? Trillions? Okay, I just want to make sure you heard me. All right, look at that. So the color coding helps you sort of see those blocks. And I want you to notice that pattern. That's going to be important to figuring out what place you're looking at in that list. Okay? Let's take a look. So let's say you had this decimal written as 0.3. Well, it turns out wherever the number ends, whatever place value that is, in this case it's tenths, that just tells us our denominator. Okay, so we know we're talking tenths. And then you just put the number that you see there as the numerator. So 3, right? So 0.3 is really a way of writing 3/10. Okay? If you had a number like this, 0.007, well, it looks like if we go through our decimal places, let's see, tenths, hundredths, thousandths, right? That 7 is in the thousandths place. So we know that our fraction will have a denominator of 1,000. We're talking thousandths. And then we just put the number we see as the numerator. Now, just so everyone's clear, I don't think you would do this. It's kind of weird. We wouldn't write 007. That's weird. We just would say 7, right? There's 7 thousandths there. Cool. The next one. Here's a decimal. Let's figure out where it ends. The 1 is in that last slot there. So let's say we got tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So we're talking about a fraction with a denominator of 100,000, 100 thousandths. All right, we put that down, and then let's just put the number we see up as the numerator, 401. We got it. Looking okay? Excellent. What if we go the other way? Got a fraction here. 1,439 10,000ths. Well, all right, our denominator is 10,000. So that means in the decimal form, it should end, our last digit should be in the 10,000th place. All right, well, let's see if we can do that. Tenths, hundredths, thousandths, 10,000ths. There it is. All right, so our decimal number, that's where it has to end. And if you notice, we've got 1,439. We can just put each of those, we can put them right in that spot. 1,439 10,000ths. Okay? How about this one? 17 thousandths. Well, again, the denominator tells us the place value we're going to end in. So let's make sure our number ends in the thousandths place. So tenths, hundredths, thousandths. There we go. Now we just need to put 17 in there. Ooh, wait, hold on. Just make sure of something. We can't put it there, right? Because if we just put it there, now we're looking at, see the 7's in the hundredths place? That would be 1700ths. So we actually need it one more over, don't we? So it needs to move over there. Now that 7 is in the thousandths place. But notice that gap? Good, I heard some murmuring. Excellent. We need to hold that place with a 0. So we'll drop in a 0, and that sort of knocks the number down, the 1 and the 7, so they line up in that thousandth place. They end up, in that thousandths place. Looking okay? All right. How about a mixed number? If we had 5 and 135 millionths. Okay. Well, all right, mixed numbers are no big deal. The 5 is just 5 ones, right? So we know what that's going to be. It's going to be in the decimal place to the left of the decimal point. So 5, and so now we got to place that 135 millionths. We need to find the millionths place. So let's go through and count it. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. There we go. All right, so 135 needs to get placed in there. So it's going to go all the way to the end, right? And then the zeros keep the places that we need to push it down there. Looking good? Awesome. Yeah, good work. All right. Ooh, that brings up a really cool idea. Percents. With decimals in the game now, we have another way of writing percents. Check this out. If you have 23%, we know that that's 23 hundredths, right? But now in decimal form, that would be 0.23, right? Because the 3's in the hundredths place, so that's 23 hundredths. Man, that's so cool. It's a new notation for this. So you want to have all 3 of those at your disposal, okay? You can write it in any way that helps with whatever you're doing, all right? Cool. Percents. All right, well, if decimals truly are just fractions in the tens family, I want to key in on the fact that they're fractions. So let's go through some things that we can use our knowledge of fractions for to really knock off some important basic ideas with decimals. Like, for example, representing decimals. Well, we've been doing this for a while with our fractions and using number bars. So tell you what, 2.3, since we know that that's really 2 3/10, right? 2 3/10, 3's in the tenths place. We got this. If you want to represent it with bars, go for it, okay? There's 1 bar, take all of that. There's a 2nd bar, take all of that. That's the 2. And now we just need to do 3/10. So 10 equal pieces, keep 3 of them, game over, right? There's 2.3 or 2 3/10. We got it. All right, even in the real world, like if you have to, like there's a gallon container and someone says, hey, can you fill that up with 0.7 gallons of milk? It's like, of course I can. I understand that. So there's a gallon. I chop it up into 10 equal pieces. Why? Because 0.7 is 7/10. 10 equal pieces. Let's fill it up with, let's do 7 of those tenths. Fill it up. Ooh, I don't know. That's either really super spoiled milk. I don't know if that's chocolate milk. I don't know. You might want to pour that out. But anyway, it's 7/10 of a gallon there, right? Looking good? No big deal. We got this. All right. Like leftovers. Let's say you eat 0.3 of a candy bar, how much is left? Same deal, guys. Since 0.3 just is another way of writing 3/10, we should probably even start saying it that way. 3/10, just read it as in the decimal form even. 3/10, I know how to represent 3/10. There we go, 10 equal pieces. Let's say we just ate those three. How many are left? Well, 7/10, clearly. All right, so if you want to write that in the new notation, 0.7 or 7/10 are left. Looking good? Man, this is nice. Isn't it nice to know stuff and then you can build on it? It's pretty cool. All right, half. All right, we know how important that is in fractions, and since we're still in the fraction world here with these decimals, let's take a look. The question is 0.7 bigger or smaller than a half? Again, guys, 0.7, let's read it the right way. It's just 7/10, right? 7/10. And since 1/2 is 5/10, when you're talking tenths, 5/10 is a half. Well, look how easy that is to compare. 7/10 is more than 5/10. So 7/10 is more than 1/2. Nothing to it. We got this. Excellent. All right, here, try this one. How about this 0.641? Okay, also known as 641 thousandths, right? We're going to read it that right way. 641 thousandths. Is that bigger or smaller than 1/2? All right, well, 641 thousandths. Half in the thousandths form is 500 thousandths, right? Well, look how easy that is to compare, right? When you're comparing to a half, you just need to know what half is. What's half? It's 500 thousandths. So 641 thousandths is clearly bigger than a half. We got it. Look at that. Now here's a quick tip. I think this is important. All you really need to do is look at the tenths place to decide when you're talking about half. Remember, half in decimal form is 0.5 or 5/10, 0.5. So let me give you three numbers here. If you want to decide if a decimal is bigger than a half, all you have to do is look at that tenths place. If it's 5 or higher, and you got other things, to the right of it, you actually don't care about it, it's going to be greater than a half. 5 or higher in that tenths place, it's greater than a half. So in this particular case, let's look at the first one. Look at this right here. Here's the number in the tenths place. That's more than 5, so game over. This decimal is bigger than a half. Let's do the same thing. Look at the middle number. Is that bigger than a half? Well, we just look right here, and since that's 4, that's less than 5. No, I don't care what's happening in those other places. I know that in the end, that number is going to be less than 1/2. So I'm not going to circle it. And lastly, 0.5078 or 5,078 10,000ths, that is bigger than a half. Why? Can you just take a second, just say it out loud or in your head? Why is that number bigger than a half? Whoa, guys, I heard that. I heard your thoughts. Yeah, that's right. Look at this. That digit, it's 5 or higher, right? That's the rule. The tip. Anything 5 or higher, game over. That number is bigger than a half. That's it. That's all you need to know. And by the way, just comparing in general, just like we had obvious comparisons in fractions, check this out. Check this out. Which is bigger? 0.7, 7/10, or 7/13? Well, wait, we just said it. If 0.7 really represents 7/10, check this out. 7/10 or 7/13. That's what it's coming down to. This is one of our obvious comparisons, isn't it? They have the same numerator, so it comes down to the size of the pieces. Well, what's bigger, a 10th or a 13th? A 10th is bigger. That's right. So, you know what? That's the bigger number. We got it. All right. You know what? Maybe we'll stop here and maybe we'll pick up next time talking about comparisons in general. Okay, like if it's not obvious or something, or yeah, we'll see where that goes. But man, wasn't that cool to draw on our fraction knowledge? Man, being as good as you are in fractions is going to really help. And we saw that today right away. Man, nice work. Guys, head off, work on these with your colleagues, and I'll see you in our next lesson. Beautiful job. See you later.